So again, we're trying to figure out for a lens, we're trying to find the DI, the image distance, we're trying to find the magnification, and we're trying to find if it's real or virtual. So first thing I'm going to do is I'm going to write my knowns and unknowns. It gives me a focal length of 3 centimeters. And it says the object is 4 centimeters away. Okay, I was being a little tricksy on this one. On the final, I would not be. It says diverging. Diverging means the focal length has to be negative. On the final, if I gave you a diverging lens, I would make it negative on the final. Like I would tell you it's a focal length of -3. I'm not going to make you, I'm not going to mess with you on that. So just know diverging means negative, and I would give that to you as negative on the final. So we got F, we got DO, and then DI is what we're solving for. So the equation is 1 over F equals 1 over DO plus 1 over DI. So we got 1 over 3, and I make the front of that negative. I don't make the 3 in the denominator negative. I just make the whole thing negative. Equals 1 over 4 plus 1 over DI. So I need a common denominator. So the common denominator I'm going to use is 12. Between 3 and 4, 12 is the common denominator. So this is still negative. I would multiply the top and bottom of this one by 4. So I would get 4 over 12. And I multiply the top and bottom of this one by 3. So I get 3 over 12. Okay. I usually try to make these numbers nice. They're not going to be that nice this time. Subtract 3 over 12 from both sides. When you do, you get negative 7 over 12 equals 1 over DI. But you don't want 1 over DI. You want just DI by itself. So you flip the top and the bottom. And you get DI equals negative 12 over 7. On the final, I would probably make the answer in a decimal, just so that people who are just putting it in that way would get that. So 12 over 7 would be 1.71. Sorry, negative 1.71. Okay, so that takes care of A. B wants to know the magnification. So you just look at your magnification equation. Negative DI over DO equals HI over HO. It doesn't say anything about HI. It doesn't say anything about HO. It just gives me the DI and DO value, so you can get rid of the H's. And you just plug the numbers in. Magnification equals negative 12 over 7. So the two negatives will cancel, and you get a positive answer. Over DO, which is 4. And the answer you get there is 3/7. Or 0.43. All right, and the only thing that's left is to figure out whether it's real or virtual. So, what is this? Is this real or is this virtual?
Virtual.
How do you know? Second? Positive magnification. So, you got a positive magnification, so it means it has to be virtual. There's one other way you can tell too. Two other ways. The other way that makes most sense is you may just know diverging lenses make virtual images always. So as soon as you see diverging, you immediately can say, oh, it's got to be virtual. Okay? All right. The one other problem that we didn't get to that I do have solved and will have on YouTube is 53. So if you are interested in checking your work on 53 or just want to see me work through a pendulum problem, that'll be on YouTube. So you can check that on there.